Hey guys, so today we want to continue our discussion of limiting and excess reactants by today actually going through the calculations required to find the limiting reactant, excess reactant, as well as the theoretical yield. So we have a scenario, and then we're going to look at several different situations surrounding that scenario. So our scenario is that we have 6.50 grams of aluminum, and that reacts with 4.23 grams of oxygen to produce aluminum oxide. So we will ask several questions based on that, and hopefully be able to gather a lot of information from that very simple statement. So obviously the first thing you want to do is make sure you know what the reactant and the products are, make sure it's balanced. So go ahead and write out your balanced equation. You should get 4 aluminums reacts with 3 oxygens to produce 2 aluminum oxide, Al2O3. So now that we have that, we're good to go. So we can go ahead and find my limiting reactant. So I only have one product, so that simplifies the process. So basically what I need to ask myself is how much product can I make using 6.5 grams of aluminum? So go ahead and pause the video, convert from 6.5 grams of aluminum to grams of Al2O3, and get your answer. Okay, hopefully you got your answer. Now you want to start a completely different problem. Figure out based on oxygen, how much product can I make? So pause the video, convert from 4.23 grams of oxygen to grams of product. Okay, now that you're back, hopefully your work looks like this. You have 6.5 grams of aluminum. You convert from grams of aluminum to moles of aluminum, moles of aluminum oxide to grams of aluminum oxide, and got 12.3 grams of product. So this is saying that if aluminum is what limits my reaction, I can make 12.3 grams of product. Then you also perform the calculation with oxygen. You convert it from grams of oxygen to moles of oxygen, moles of oxygen to moles of Al2O3, moles of Al2O3 to grams of Al2O3, got 8.99 grams. So now you're saying if oxygen limits me, if I run out of oxygen, then I can produce 8.99 grams of product. And that should be a reaction arrow. I'm not sure why I printed the box, sorry about that. So now I have 2 different amounts of product. I need to decide which one to look at. So if based on aluminum, I can make this much. If based on oxygen, I can make this much. How much can I actually make? So the answer is 8.99. I can only make 8.99 grams. So 8.99 grams is my theoretical yield. So that means that oxygen is my limiting reactant. Because oxygen produced the smallest yield, that means I'm going to run out of oxygen first. So oxygen limits my process, therefore it's my limiting reactant. So that means aluminum does not run out. If there were more oxygen, aluminum would be able to produce more product. Therefore, aluminum is my excess reactant. So at this point, you want to go ahead and put an X over 12.3 grams. You do not ever want to use the number of grams of product that are produced from the excess reactant. So go ahead and cross that out, that way you don't accidentally grab that number later. So now I have 3 pieces of information. I know that oxygen is my limiting reactant, aluminum is my excess reactant, and my theoretical yield is 8.99 grams. So based on this information, this amount of aluminum, this amount of oxygen, if everything goes perfect, I can produce 8.99 grams of product before I run out of oxygen. So now let's move on to the next section, the next question. So it says, based on the previous question, I apologize in the notes. In the notes, I believe the 6 got cut off. So the next question should also say 6.50 grams of aluminum, not just 0.50 grams. I apologize for that. So 6.50 grams of aluminum. So the same situation. I asked you to calculate the theoretical yield, which you've already done that. So when you're asked for the theoretical yield, at this point, you've already done that. So just go back to your 2 yields, select the smallest one, that's your theoretical yield. But now I also ask you how much excess reactant is left over. So that's kind of an interesting question. So I use up all the oxygen, but there's going to be some aluminum left over. And I want to know how much aluminum is left over in this process. How much aluminum did I waste? So just like before, we have to go through, balance the reaction, and you need to know which is limiting, which is excess. Right? That is, sorry, I choked on my coffee there. I'm not sure what I was saying. I'll start over. You gotta know which is limiting and which is excess. You cannot solve for how much excess is left over if you don't know which one's in excess. So I know that aluminum is in excess. I'm gonna not use up all of it. So I want to know how much aluminum is going to be left over. So you always want to start these calculations with the limiting reactant. And so I already determined that I can make 8.99 grams of product. And I know that I'm going to run out of oxygen. So I'm going to use up all 4.23 grams of oxygen. So I'm going to use that up. So what I need to ask myself now, if I, in the process of using all of this up, how much aluminum do I need? So can I convert from 4.23 grams of oxygen to grams of aluminum to see how much it's going to react with? Yes, I can. So if you want to write it out in words, and I would highly advise that, the question is, 4.23 grams of oxygen needs how much aluminum to react? So 4.23 grams of oxygen needs how much aluminum to react? So I can do that. Convert from grams of oxygen to moles of oxygen. Moles of oxygen, moles of aluminum to grams of aluminum. So based on that calculation, I see that 4.23 grams of oxygen, which I'm going to run out of, requires 4.76 grams of aluminum to react. So I know I'm going to use up 4.76 grams of aluminum. But that wasn't the question. The question was, how much aluminum is left over? How much am I going to waste? So to do that, I subtract. I started off with 6.5 grams of aluminum. I used up, or needed, 4.76 grams of aluminum. So now I have 1.74 grams of aluminum left over. That's how much I wasted. And so I made a note in your notes. It says, when calculating excess left over, ask yourself, how much of the excess reactant was really needed? Okay, so I figure out how much of this I really needed to use. And I will tell you, there's another way to get the correct answer. I could have come up here, grabbed my theoretical yield, and I could have converted from 8.99 grams of Al2O3 to grams of aluminum and got this exact same answer. Because what that question would ask, and you can write this question down as well, in order to produce 8.99 grams of product, how much aluminum do I need? And it works out, if you do the math, you get the exact same answer. So there's multiple ways to get the correct answer there. So feel free to do what you want. Okay. So now it asks another question. We're asked to find the percent yield. So it gives you the same situation, 6.5 grams of aluminum reacts with 4.23 grams of oxygen. The excess is aluminum, limiting is oxygen, we've done that already. You have 7.86 grams of product that recovered in lab, calculate the percent yield. So to solve this problem, we need to plug in the percent yield formula. We need the actual yield. We know the actual yield comes from the lab setting. So I already have that number from the lab setting. The theoretical yield comes from the calculations, and I already found that to be 8.99 grams. So I can just plug in 7.86 divided by 8.99 times 100, and I get 87.4%. So that means that 87.4% of the product that I thought I would produce, I actually did produce. So this is a note here at the bottom. Theoretical yield will always be greater than actual yield. If you do things correctly, that is true, okay, because you always have to get, or you can never produce more than you predict, okay? The actual yield in lab cannot exceed how much you think you're going to produce. However, in practice, this situation is not always true, because sometimes our actual yield is contaminated or tainted, because some of the, what we think to be product that we're weighing might actually be some other substance, so it skews our numbers. So be sure and watch out for that. Okay, so at the bottom of the notes, there's a problem that's left up to you to practice. It says 12 grams of oxygen is used to combust 12 grams of methane. 4 grams of CO2 is produced, what is the theoretical yield, what is the excess left over, what is the percent yield. And so I'll leave that for you, and go ahead and try that on your own, and I will make another video working through the problem and kind of explaining the process. So.